right, good afternoon. Oh shoot. Something out, I thought it rang along. Oh well. I want to make a couple comments about some things I saw in all the flurry of grading that I did today. This is my C++ day from 9 a.m. to 2:30, and then some. Just grading this stuff. That's why it's got to be turned in on time. So I want to go over a couple things, and then get to this week's and next week's, and that's probably it. I think next Tuesday I won't hold this. So if you have individual questions, come on by, but I don't think there'll be any review, and part of that's by the fact that my seminar class that starts at 2:30 might not be over before. So I buy myself a little bit of time there. Okay, so. Some things I saw for the shapes class. Let's see, actually the shapes class was fairly good. There were a couple mind benders. Sarah had something that was just strange numbers showing up in her points of the shapes, and don't know how they got there. And I was baffled. But for the most part, that looked all pretty good. I'm just glad to be done pushing 13 files around. The little IO stream exercise, again, for the most part, was okay. One thing that I've seen all over the semester, and it's sort of, I think, maybe just bouncing around to different people, and I suspect it's something I need to explore with Visual Studio. I guess Visual Studio allows you to create main programs that are type void, right? But when I compile void main programs, I get an error, and I have to go change it. So for your information, main programs should be int, right? It's it's been a long-standing standard thing. Main programs would be int. Visual Studio is thinking, oh, you're running this on a PC, a Windows machine, and we don't look at what programs return. We ignore it. So main programs can be void. Right? Unix, on the other hand, does look to see if there is a return value. And that's why a main program should have int in it. Whether it's ignored or not, it's immaterial, just as a standard approach. So I'm just telling you, for just as a general principle, main programs should be of int type, not void, even though it might compile for you. It doesn't for me. And I think my compiler is also generating an awful lot of other warnings that you must not see. Or if you're ignoring warnings, you should stop ignoring warnings and you should resolve them. Right? So if you are getting warnings, yeah, you get a compiled program that you can test and it may work. But 90% of those warnings are telling you something that's probably of value. And you might actually find scenarios where your program breaks because you have not heeded those warnings. So again, I don't know. It's the difference that I'm running on my terminal window on my Mac. I'm running CLang compiler, which actually is a C++ 11 compiler. and you're compiling on, maybe a lot of you're compiling on Visual Studio, and I don't know, I might be getting a different set of warnings, but generally I will, ignore them and go on and see what happens, but oftentimes, I bet half the time, I have to fix those warnings for your program actually to work, really work. So I'm not sure what you're debugging. So, all right, moving on. Couple more things, two more things with the Stream.io. And I should have coached you on the one here. So when you are inputting 15 characters into an array of 10, right? Your input's going to stop because it filled the array. What's left in the input buffer is more characters that you typed. And they sit there and will be consumed on the next input. So when it was supposed to look for a string that terminated with a period, it probably didn't find one. So if you have a scenario where your input may actually have more stuff in it that you need to ignore or discard, you really should ignore it. So at the point at which you want to get rid of the current input line so that it synchronizes with whatever happens afterwards is cn.ignore. Put some fairly large number here, 255, 90, 80, something that will pretty much throw away whatever extraneous characters there are. I wouldn't go with something like somebody had a 10. I thought, well, that's a little bit on the low side. But 255 is good. But the important piece of it is the second parameter to say that discard everything up to the new line character, which is exactly what you want. That's akin to end out, right? I coached you early on at the beginning of the semester to put end out in your couts to flush the stuff out of the buffer. This is the input version of that. You're flushing the stuff that's sitting on your input buffer that you want rid of. Now this one you get rid of it. This is pushing it out so you see it. Okay. Cout.flush. All right. You could also do that. I think. But that's the input counterpart, sort of. Yeah.
If you leave the parameters on ignore null, does it just flush the input completely?
It would actually ignore the next whatever. You normally would put some kind of delimiter there, and it would be the new line character. Now, I have no idea what happens if you put null there.
Yeah.
It probably ignores then whatever number you have here, literally all the way. So you would sit there and type until that's satisfied. Would be my guess. Part A, you would print 4,444 in a field of 13, surrounded by slashes. I don't know where you got the filling in with slashes. I wanted it surrounded by slashes. So what I wanted to see was 4, 4, 4, 4, blank, 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 slash. That's what I wanted to see. I wanted to see blanks there. I don't know where you got the idea. So many of you put your heads together and said, oh, he must have meant slashes in there. I don't know where that came from. Surrounded by 4, 4, 4, 4 in a field of 13, surrounded by slashes. That's what I meant. Clear? Because basically I just wanted to see that there were 9 blanks there. Okay. Then Elena decides, well, blanks aren't good enough. I want to see them. So she puts in asterisks. Okay, so here's what happens. So I copy and paste my run, okay, to the, as I do. and this would always end by comment block. So I had to go in and unedit that so that the comment blocks would work. Thank you, Linda.
I'm sorry. I did have for debugging purposes, but I never.
I understand. You make work for me. That's all right. That was cute. That was an interesting, nice idea. I know you wanted to see that there were 9 other blanks. But. All right, those were comments I saw for the Stream.io. A couple of you still, you input the information, then print anything out to verify it, which I thought was, come on. By the end of the semester, you should know what I'm looking for. All right. So this Friday, you are adding exception handling to the rational class. All right. Some of you have dabbled. I could see some throws already ready to go in some of your code. That's fine. So now activate it. So let me remind you, in rational.cpp, I should only see throws. You throw, there should be no outputs now. Right? No error messages. Get rid of the error message. Where you would have put an error message is now a throw. Throw the exception. Throw a useful exception. Make the exception contain a useful error message, please. Right? But try to minimize the number of places that you need to throw. Right? Again, wherever a 0 could show up in the denominator, constructor, division by 0, dividing by your second number actually legitimately has a numerator of 0, but now you're dividing, so it's going to cause division by 0. And reciprocal would cause that. All right, so there you go. That's where you should be implementing throws. Question? I got it? Okay. Then you should catch in your main program. You should catch judiciously. All right, catch as narrowly as possible. Where could you do bad things with zeros and denominators? And handle them. Handle them with a nice message and keep on going. It's not handle it and stop. I want to be able to do the program as completely as possible. That's your goal. Is be robust. Handle the possibilities. Robustness is not, I'm going to stop. If you're going to just stop, then don't bother with catching and throwing or trapping and throwing. Just let divide by 0 stop your program. Right? The purpose of catching them is so you can handle them. So, for the point at which you open or create a rational number, if a 0 is creeping in the denominator, you need to throw it back, but your main program should allow the user to re-enter a valid rational number. So that's going to be now a loop. Right? So where you might have, your 2 CNs, you've got a CN numerator, CN denominator, and now you're going to create, your rational A as N and D, okay? That now needs to be, I should push that up. Well, no. I'll leave that there, sorry, I should have put that alone, CN, D. All right. Put this now in a try, right, and catch. All right. But since we may need to allow the user to re-enter that, you may want to enclose all of that in some kind of do-while. And have some flag. Good equals true. And then if you catch something bad, good equals false, while good equals, well, not good. Now, I don't need to say, you have me doing that now, good equals true. How redundant is that? While good. Yeah, this is messy. Exception handling is not pretty. It is allowing it to be fairly robust, but where you might need to handle, especially in this case where I'm trying to input a rational number and I keep insisting on a 0 in the denominator. Okay. I'm caught in a loop until I get it. But in the catch block, not only do I set good equal false, I should print a message saying you can't have a 0 in the denominator. Re-enter, please. Get the idea? I know it's sketched out here. So where the user might have to re-enter, then okay. If division by 0 occurs or the reciprocal of a legitimate 0-based number occurs, you catch it, print a message, and then keep going. There's no looping there, right? Division by 0 is that's going to happen. You just say, oh, division by 0. But go on, don't stop your program because there probably was a lot of other code to test. Take your existing main program and just be sure that you put in the appropriate try-catch blocks. No super try-catch blocks. No, just one big try-catch block. Because that will allow you to skip code. I don't want you skipping code. Right? Division by 0 is going to go on fine. Just print division by 0, but then go on and test for equality, test for inequality, test for less than. Do the reciprocal. Oh, division by 0 again. Just print the message and go on. Okay? Questions on that? And then the final project, and I meant to, I really didn't change it from what was there. I did clean up the wording a little bit, but I didn't enhance it because really it's not essentially the same as the exercise is stated. So I'm giving you a person.h file and a person.cpp file. You shouldn't have to do anything except put your name in the comment block. Oh, comment blocks, please, yeah, forever. Still do that. Somebody sent me a comment, sent me last week's project with no comments. Really? They failed somewhere along the way. So those two files you shouldn't have to do a thing with. And then the main program is seriously a template with just a lot of comments where you need to put in code. That code you can lift from the book. Okay. The book has a lot of this code in separate programs. And what I'm wanting you to do is put the whole thing in one program so that you can manage this file all from one place. So it really is just a matter of finding the right file code that you are using. So that's essentially the project, is filling in the blanks. But let me talk a little bit about random access files. Reading sequential files and creating sequential files, writing sequential files, is fairly straightforward. Those are just considered streams of text, streams of input, streams of output. So instead of cout, you would have another file variable, and you would just If you're outputting to a text file, it would be text file, less than, and whatever it is you want to output to the text file. And of course, you have to open it, so you would see in the book how to open it. So you have one extra statement at the top specifying a new output stream that you would use instead of cout. Similarly, for input, you would just establish an input stream and you could use cin type of input. So that's kind of humdrum, and I think you can figure that out. All right? But what might be a little different for you is this idea of a random access file. It's a file you open that can be used for both input and output. So this is like a little database where your data is going to be stored in a file. You have the ability to say, give me the third record. So you think about your file now as a big array. Record 0, record 1, record 2, record 3, record 4, record 5, record 6, etc. Right? So these are records. Okay. And so what we've got here is a person record. Right? That structure is defined in person.cpp and person.age. Right? So you've got getters and setters. So it's a person record that will fit in and lay out in this file. It has a size of person. So you have this person object. Size of person is the number of bytes that is taken up in the file for one of those records. It is a consistent value. Let's just say for our talk this afternoon that this is 24. Let's make it easier. Make it 20. Let's make it, let me make it 30. Let's say 30. I can do the math. Easier with 30 than 24. Okay? So what that means is the first 30 bytes is record 0. The next 30 bytes, starting at 30, so 0 to 29 is record, the first record. If you don't mind, we'll still call them indexed like we do arrays. Okay. The second record, or record 1, starts at byte 30 and goes to byte 59. 2 is at 60, 3 is at 90, 4 is at 120, 5 is at 150. So yeah, the math is easy. Okay? So as you look at the code in your book and you see, okay, I want record 4. Okay, now again, are you counting from 0 or are you counting from 1? Generally in files, we actually start with 1. So if I want the 4th record, probably that one. So you say the record number -1 times the size of the record. That gives you the offset. So these are offsets. All right? This works as long as the records are a consistent size. All right? Now, you don't determine that size. You let the computer determine that size, and you take advantage of the size of function. It's sort of a meta function. The compiler actually knows it. You can get size of, you can put size of int in there, size of double, and it'll tell you it's 2 or 4 or 8. It's the number of bytes that particular data type takes up. But if you create a structure or a class, the instance variables that make up that record, size of will tell you how many bytes there are. All right? And so This is considered still a byte stream. Unix in C, because C came out of the Unix environment, C++ then, it views files as nothing but a stream of bytes. But you are going to open this file and say, I'm going to do both reading and writing. So what you then have to do is determine for which record, where in the file does that exist. If you screw it up, you screw it up. Right? So you better make sure your calculation is correct. It's not a hard one, right? It's the record number minus 1 times the size of the record. That's your offset. A very standard, it's a very standard array address calculation. It's just now we're doing it to a file. Now, what you do with that offset is use it in preparation for input or output. So either you're going to read a record from the file or input from it, or you're going to write a new record to that. You're actually going to just replace the 30 bytes there. Okay, that's writing. Okay. Before you read or write, and the functions are, in fact, I have to look. Write, W-R-I-T-E, and read, surely, must be read. Pick out something here. How many? It's got to be read. I'm not seeing your read. It's read, thank you. There. But prior, so you have dot write and dot read. But prior to the reading or the writing, you must determine where you are in the file, and you do that with a seek. S-E-E-K. Okay? And there are two seeks, actually. One is seek P, not seek W, I don't know why, but it's seek P. Seek. Right? Where you actually pass in the offset. And what that does, it moves the file pointer to that location. You must seek before you write. Well, I take that back. For a random write, you must seek. If you seek and then you do two writes, you actually will seek to one location and then you will do a sequential write from that point on. Okay? So you can write sequentially. But if you want to start writing in an arbitrary point, seek to it. And again, if you screw that up, if I go seek 55, holy grief, I will start writing records that will be five bytes off. Good luck debugging, and I hope you didn't lose data, important data. Seek P before I write, seek G before I read. So the seek does two things. One, it establishes where in the file you will continue your input-output. And it also determines which mode you are doing to the file. Are you inputting or are you outputting? P sets for output. P for put. G for get. Let me say that again. P stands for put, which means prepare for output. G stands for get, preparing to get data from the file. Right? Put and get. I worked in a programming language, PL1. That was the file input output. Put wrote and get got from the file. Right? We didn't use reads and writes. It was get put. So, these terms show up in funny places. You can also get to a location, seek G to a location, and you can read sequentially from that point. Right? You want to read this file over and over and over, you can do a seek G0. Standard way to just go to the beginning of the file. Then read. Sequential read. You want to wipe out what was there and overwrite it? Seek P0. And then put, or write, and you just overwrite. So you can do you can do more reads and writes without the seeks, but realize that they're going to overwrite. Now, if I want to change a record, so you're going to have the ability to add records, the ability to remove records, the ability to retrieve a record, and the ability to update a record. Update, what you've got to do is calculate where it is. You seek you seek G to that record. Now let me note that, update. So you will seek G to the record, well, calculate the offset calculation. Then you seek G to the offset. You will read that record. And you read that record into a local variable, an instance of person. So you will read it in, and you've got code, you've got example code that you will lift and put into this program. So you make your changes. Right, you might ask the user, oh, do you want to update the name? Do you want to update the age? Do you want to update whatever? Make your changes. Then you must seek P. You must seek again. It doesn't, so when you read a record, the pointer that is offset, it moves to the next record. So if you don't seek P, first of all, you'll be in the wrong mode because you shouldn't be able to write immediately after a read without changing the mode. So seek P sets that mode to putting, to writing, right? But if we didn't, and some systems don't require you to switch mode, if you didn't re-seek to the same location, your put would actually overwrite the next record. Whoops. So you need to seek P and then write. And I think if you look at the update program, there surely is one. Yeah, there's a transaction processing program here, I think. Update record is 2. Yeah, update record, I'm looking at 682, but I'm in version 8. Yeah, you do a beginning of the update record is a seek G, you do a read, you make the updates, and then you do a seek P, and you do a write. That's how I remember it. The adding of a record is the user can choose like an ID. You can use the record number as the ID number. So write it wherever. If you decide, to write to record 100, you literally will go down to record 100, which would be what at byte 3000. Offset 2970. That would be record 100, right? Okay, and so that kind of automatically creates 99 other records. It will allocate. So if you just seek P to some huge number, you will actually create that space for everything in between. Be careful. I'm sure that's what you want to do. So that's what you're doing for next week's project. That wraps it up. The following week is just a reflection paper. you don't do that, I take 10 points away or something like that. Humor me with a reflection paper. It's not hard. That's how I view its humor. I mean, no, I hope you take it seriously and you find that the process of this course was useful. Anyways, anything with random files, random access files. You know, it's just kind of an interesting process to think about. Fortunately, there's not a lot of real data sets that use this anymore. I mean, typically you interface to a database and your data sits in a database and you've got to figure out how to use that library of database methods to pull your data, store your data, pull it out. So this may be more of an academic exercise than it is as practical. But I do think it's worth, you know, one never knows if you might encounter a system that might be using a random access file. You should know what it is. Any other questions?
For the instructions for the update portion of the program, I think it says just to let the user update the age. Do you want us to?
Yeah, I just want you to get the gist of it. We don't need to make this so complete and robust. Okay. Yeah, C++ is a little bit flexible with, you know, we're not doing a lot of exception handling here. Java, on the other hand, would just be killing you with all these try catches that you have to surround everything. C++ says, well, whatever. You know, if you want to catch it, okay. If not, whatever. You could put try catches in, but you don't have to do that. Anything else? Am I what? You can't read my handwriting. Oh, surely by now you can. Update, offset, calculate the offset. Seek based on the offset. Read whatever changes you are going to the record, and then seek. Of course, you would repeat the offset. Seek P to the same offset. That's the key thing, right? That's got to be the same. And then you can do the right. Anything else?